All right, so today's really gonna be just an extension of yesterday. So what today's the 32nd, today's the 2nd. Just looking at day 2 of these exponential growth and decay functions. We're gonna be looking at the transformations, the shifting and stuff like that. Just real quick, just a reminder about what's happening here from yesterday. You wanna look at that base value first off and just compare those. What's bigger than 1, that's going to be a growth function. We should be expecting that graph to curve up and to the right. Less than 1 is a decay function. We're expecting that graph to curve down to the right. And both of those functions have an asymptote, which is a new word we talked about yesterday, at y equals 0. That line that graph is going to get closer and closer to, but never across. Okay? And both of those functions had the same domain and range that we saw. That was kind of set yesterday with what we were doing. But today we're going to see the range get messed with. Okay. But what was different? So I talked to you guys about throwing some numbers at it. We saw that -1 and 0 and 1 worked well as far as giving us values to use. So we take 2 to the first power and we get 2. We take 2 to the 0 power and we get 1. We take 2 to the -1 power and negative. Let's give us fractions, not negative answers. And so we tried plotting those points and graphing it. Just that idea that it's a curve, right? And on that left side, it gets really close to the asymptote. On the right side, it gets that steep curve up to the right. So flat along that asymptote and then curving. That's not great. Up to the right like that. Arrows on both ends. Should look something like that, but better. You guys should draw better than that. And then the 1/2 would just kind of be the, then end up looking like this. I'm not going to do it, just save time, but it would end up looking something like that. Right? Growth versus decay. Up and to the right, down and to the right. Right? Growth versus decay. But a lot of similarities otherwise. So we're going to look at those transformations. Okay. You guys have done all of this multiple times. So now this should be too big of a deal. Reflections. Reflections come from negatives. Doesn't matter if it's a growth or if it's a decay problem. It's still just a reflection. So -2 to the x, or -1/4 to the x. Okay? That's a reflection over the x-axis. So taking that curve, we're just flipping it down. Okay? Instead of curving up and to the right, then it would curve down and to the right. Okay? So we would go this way. That would be a reflection of the x-axis. Stretch. That's like a times b to the x, where a is bigger than 1. What's going to be a little bit weird here with the stretching is that you're going to have 2 numbers, so that maybe it's 2 times 4.2 to the x. Okay, which of those is the stretch and which of those is the function? Okay, when I write these, I always put that base here in the parentheses, so you can kind of make sure you're connecting those things here. The 2 would be the stretch. The 4 would be the function. The 4.2 would be the function. It would be a growth function that's being stretched. I want to point out really quickly, you cannot just take those and multiply them. That does not equal 8.4 to the x. You cannot do that. Okay? Order of operations tells us we are not allowed to do that. I can also stretch a decay function. Maybe it's 1.7 times 2/3 to the x. Okay, so just kind of paying attention to the difference between these numbers. I think it's kind of a weird thing. This is the stretch. This is the function. That's bigger than 1, so it's a stretch. That's less than 1, so it's decay. That's bigger than 1, so it's a stretch. That's bigger than 1, so it's growth. So this would grow faster. This would decay faster. That's what the stretch would do to it. Vertical shrink, same place, a times b to the x. So for now, a is between 0 and 1. Right? So a is some sort of decimal, a is some sort of fraction that's less than 1. So maybe we have something like 0.5 times 2 to the x. So there's a shrunk growth problem. Maybe I have something like 1/5 times, and I'm just making up numbers here, 0.9 to the x. Okay? There's a shrunk decay problem. It would decay slower. It would grow slower. Up and down translations, those happen after the function. So b to the x like plus k or b to the x minus k, doesn't really matter. You guys don't need to write both of them if you don't want to. And that would be an up k units versus a down k units. So you might have something like 2 to the x, then plus 5. I'd be shifting that graph up 5. 1/3 to the x minus 2. Right? That would shift the graph down 2. Like for me, probably the strangest one is the horizontal shifts. Horizontal shifts happen in the function, right? We put them in the parentheses. They were under the radical. The function is the exponent. That's where the x is up in the exponent. So when you see this b to the x minus h, right? So notice how it's up in the exponent, right? And then, of course, what we know about h is a liar, right? If I said something like 2 to the x, then minus 4, well, that's a right 4. Right? So just notice how it's up in the exponent, right? Versus here it's just after after it, up in the exponent spot versus just being straight up after it. Again, like 1/3 to the x plus 1. That would be a left 1. But for me, that's kind of the weirdest one is that left and right shift. Everything else kind of acts and looks exactly like it always has. Again, just kind of watching out here with the multiple numbers here can sometimes be tricky. But the thing with the exponent on it is the function. The thing that's in front of that is the stretch or the decay, or the stretch or the compression. I'm going to stumble over compression and decay and stretch. I just know I am. I'm doing it all the first hour. I'll try to correct myself. Okay. Yeah, this should be like the 5th time we've done this stuff, guys. So it really shouldn't be too big of a deal for me to give you guys and say, hey, describe the transformations. Okay. So is there anything you guys need here before I flip to the other side real quick? So I just kind of have you right off the bat, just to think about confusion issues that could be there. Look at the function, right? The original f of x. Here's our original function. Then go to look at g and say what's the same, right? Those pieces are the same. I don't need to talk about that. Okay. What I need to talk about is what's different. Hey, this one's got a +1 and a -3. I need to make sure I talk about that +1 and -3. And look at the number 3 down there. F of x equals 2 to the x. G of x equals, there's my 2 to the x. All right, what's different? Ooh, I've got this 1/3 here. I need to make sure I talk about that. I was looking over here real quick. Here's f of x equals 3/5 to the x. G of x, 3/5 to the x. Okay, what's different? Ooh, I've got this negative. I'm going to make sure I talk about that negative. Okay. Your e to the x, g of x equals e to the x. What's different? Ooh, I've got a 4 I need to talk about. I've got a 2 I need to talk about. Okay. You don't need to talk about the function, talk about what's different about the two functions. Okay? Just kind of paying attention to that. All right. I always just go left to right, so the first thing I see here is that +1. That's in the exponent. All right, it's in the function. That's our left and right shifts. I know it's a liar. So that says +1. That's actually going to be a left 1. And make sure you have your verb shift left 1, and then with the shifts, we use the word unit. I've seen some students being a little sloppy with their vocabulary here. And I kind of highlight that again. So when we talk about shifts, we use the word unit. 3 is after the function. That's our up and downs. That's going to be a shift. We trust that one, so it's down. And 3 units. So with shifts, we use that phrase unit. All right, we're just talking about moving boxes. Okay. I'm just going to drop down to number 3. There we see a number in front. The number is less than 1, so that's a compression. That's a vertical compression. Or a vertical shrink. We do need to say vertical because there is a horizontal one. We don't talk about it much at all in this class, but it does exist, so we do need to discern that. So vertical compression or vertical shrink. And again, kind of the vocabulary side here, the notation side here, so some of you guys being kind of lazy about or not remembering is by a factor of. When we talk about compressions and stretches, we use the phrase by a factor of 1/3. Because we're multiplying those y values by something. Multiplication implies factoring. Something times something else is a factors of whatever. So those are things I look for when you guys do this stuff. So some of you are being a little bit sloppy about that. Looking over at 2, see that negative there? Negatives are reflections. You can say a vertical reflection, or you can say reflection over the x-axis. Again, there are horizontal reflections. There are reflections over the y-axis. We just don't do them. I prefer to say reflection of the x-axis. So one of those two phrases would be the right thing to say there. So what about 4? What's one of the transformations on 4? Left 2, okay. So make sure you use all your vocabulary though. Still, shift left 2 units. Negative still. What about that 4? What's the 4 doing? Dawson, what's that 4 doing? Close, Stella. That'll be a vertical stretch. Yep. It's not by 4 units, by a factor of. So shifting gets units, stretches, compressions get by a factor. Anything there you guys want to talk about before we move on to the graphing? Well, you guys are lucky that my first hour as guinea pigs, we did number 5 first, and it turns out it's probably the hardest one of these to do. So it kind of melted some of their brains right off the bat. That wasn't good. We're not going to do number 5 first. We'll look at number 6. We're going to graph the function. We're going to find the domain and range. Really what I want you guys to think about is that you want to do basically what we were doing yesterday. Okay? And so we're just going to start with that base function. Okay? We'll come back and talk about the stretch later. Okay? But you just want to start with that base function. So think about what how we would have done that yesterday. If it just said g of x equals 1/2 to the x. Okay? And we're just going to use those same points that we used yesterday. 1, 0, and -1. Okay? Of course, 1/2 to the first. Anything to the first power is itself. Anything to the 0 power is 1. When we take a fraction to a negative, we get its reciprocal, which in this case would just be 2/1, or more easily 2. Okay? That's all you guys would have done yesterday. So I'm going to go ahead and plot those points. Start to see the curve, but it's not much information. And if you feel like you want more points, you can certainly get more. I would start getting points off to the left, like, hey, what happens if I plug in -2? Hey, what happens if I plug in -3? Okay, I want more points. I want to go towards the upside, not towards the downside. Okay? That's choice there. This would be the minimum, would be getting these 3 points, though. Okay? What else do we know from yesterday? All right, one of the key features of the graphs yesterday was that idea that they have asymptotes. Okay? So the asymptote is supposed to be at 0. Okay? Don't draw that in yet. I just want to talk to you guys about that. Okay? The asymptote is supposed to be at 0. Right? So these are where the points should be. This is where asymptote should be. But we're changing the function. We're doing something to it. Okay? So how does the 4 affect these points? Does the 4 affect the asymptote? I told you guys that stuff might, and the range is going to get messed around with today. So does that 4 have an effect on those things? What's a 4 do? Okay. What's the purpose of what, Brooklyn?
The asymptote.
Really, Brooklyn, the asymptote's there for our eyes. Okay. That we want to see that there's kind of a limit to where the graph can go. Okay? That as we take these x values and make them bigger, right? If I raise 1/2 to the first power, I get by 1/2. If I raise 1/2 to the second power, what's 1/2 times 1/2? 1/2 times 1/2, Brooklyn. Not 1/2 plus 1/2. Times 1/2. What's 1/2 of 1/2?
A quarter.
Yeah, a quarter. Right? 1/2 times 1/2 would be 1 times 1 over 2 times 2. Right? 1/4. Right? So we see that y value is smaller, right? What's, if I take 1/2 of that, 1/2 of a quarter is an 1/8. 1/2 of an 1/8 is a 16th. half of a 16th is a 1/32. Right? Those y values keep getting smaller and smaller, Brooklyn. Right? As we head off to the right, as I make those x values bigger, those y values get smaller and smaller and smaller. But they never become 0. There's no number I could ever take 1/2 to and get 0 as an answer. And they would never become negative. There's no number I could take 1/2 to and get a negative answer. So what we're seeing with that asymptote, it's really for our eyes, is that there's a limit to how low these values go. That they'll get closer and closer to 0, but they'll never actually reach 0. They'll never get below 0. So we draw that line there as kind of like a little wall. Like, hey, watch out! The graph's going to do this. The graph's going to be curving down, but it's not going to do that. Right? It's not a line. It's not going to keep curving down and down and down and down. Yeah, there's a limit to how far down it can go. So we saw it scoot along that asymptote. Right? It went really. I told you guys to just kind of draw it parallel to that because that's really the best that we can do. But mathematically, it's supposed to keep getting closer and closer and closer and closer. Okay. So the asymptote is there for our eyes to act as kind of a wall, kind of a limit, saying, hey, your graph will never drop below this or above this if it was the other way around. Does that make sense? Whereas on the other side, it is just going to keep getting bigger and bigger and bigger forever. Okay? Yeah, it's just, so it's very, very visual for us. Just like when we did the axis of symmetry with the parabolas, right? We could plot one point here, and then we could say, oh, that's 2. I'm just going to go over here in 2. Right? And then, oh, this one was 1, so I'm just going to go 1 over, and I can draw another point. Oh, there's my vertex, and now I can draw my parabola. Hey, look, I got 6 back. This guy's buff. You guys see it? Okay. So, okay, so it just acts as like a visual limit for us. Okay. That's on the team. All right, hold on a sec. Let me get rid of this. Not that. So the 4 didn't. No, I have not gotten to the 4 yet. Okay. So there's where the points are supposed to be. There's where our asymptote is supposed to be from what we saw yesterday. Okay. What's the 4 do? Right? How do we stretch points? Right? How do we stretch values? Okay. So stretching, right, should make it taller. Okay. What you do, how do you do this transformationally, is you look at this distance here. How far away is that from the x-axis? Well, that's 2 units away. So that stretch is going to make it go 4 times that. Well, 4 times 2 is 8. Here's 5. So stretching that, so this is 2. So I'm going to go 8 up. That's 4 times further away from the x-axis than the original point. This is a distance of 1. So I'm going to go 4 times that away from the x-axis. So there's my stretch on that point at 4. This has a distance of a half. 4 times a half is 2. So there are those points stretched away from the x-axis. Obviously, I don't want to draw all these stupid arcs all over and make my paper messy, but that's how I'm thinking. Okay? So that was 2 units away here. So I went 4 times that away, 8 units away. That was 1 unit away, so I went 4 times that, 4 units away. That was half a unit away, so I went 4 times that, 2 units away. So that graph would look like this. That left side is still gonna, or sorry, the right side is still gonna start approaching that asymptote. I didn't draw it, very far. I would still start approaching that asymptote, heading off to the right, getting closer and closer. That left side is gonna shoot way up. You guys don't need to draw this one. I'm just drawing it so you guys can see it. Here's what the original function would have looked like. All right, can we see how that green one has been stretched away from the x-axis? It's been pulled up. And it's growing faster, or sorry, it's decaying faster than the original function. Okay? It's steeper over here than this one is. Okay, so it's a faster decay. So I took each of those distances and I made it 4 times longer. Okay? That's one way to do this. Okay? There is another way which basically just deals with these points over here, but it can be pretty tricky. On this one, it seems pretty easy, but I don't want you guys to get too fooled into thinking that it's really easy to do this. Okay? With a stretch, all I need to do is multiply the y values by whatever stretch I'm doing, or a compression. So that would now be 8. So we plotted -1, 8. There's our point, -1, 8. We plotted 0, 4. Right? There's 0, 4. Then 1/2 times 4 is 2. So we plotted 1, 2. So there's 1, 2. Right? So there are the 3 points. -1, 8, 0, 4, 1, 2. Stretching and compressing is pretty simple. If that's all there's going on, you just take those y values you got from the original function and just multiply them by whatever the stretch or the compression is. You will get your new y values. The shifting stuff is kind of messy. That's why I don't want you guys to rely on this too much. Okay? But it is an option if you guys want to try it. Did we mess with our asymptote? No. Stretching will not change the asymptote. So you can go ahead and draw that in. Okay? Or I do want you guys to draw that in, or at least label it. Okay? Stretching or compressing will not mess with the asymptote. So that just pulls the things away from the axis, doesn't change where that level is. So that will not change this. And it will also not change our range. Our range will still be 0 to infinity. Notice that it's getting closer and closer to 0. Right? It's just above 0, then it goes up forever. So still that same thing we saw yesterday. You can never change the domain. It's everything. Okay? That'll never change. We can stretch it, reflect it, shift it, do everything we could possibly think of. The domain will still be plug in any number you want. But stretching, compressing will not change the range or the asymptote. So again, what I want you guys to do is look at the base function, generate points from that, and then we're going to talk about how to mess with them according to the transformations. Okay. Let's look at 8. So when I say look at the base function, what's our base function here? What do you think, Mike? That's the whole function. It's the basic. Well, what part of that would we have seen yesterday? F of x equals 1/3 of x. That's the base function. But today we're talking about adding in those transformations, the shifts up and down, left and right. Okay? So this is the base function, right? We're not talking about the +4. We're not talking about the -2. Right? What would we have talked about yesterday? Would have been just this part. So that's where I want to start. Okay? How would I have graphed this yesterday? Then I'll worry about the 4 and the 2. Okay? So I'm going to go to make a table. Same 3 values. Chad, what's 1/3 to the 1 power?
One-third.
Okay. Easy. Jasmine, what's 1/3 to the 0 power? Good. 1. Tatum, what's 1/3 to the negative 1 power? Lucas, what's 1/3 to the negative 1 power? Yep. All right, Stella, 3. Okay. Flip the fraction. Okay. So 1/3 becomes 3. 3 over 1. Okay. Now, notice how I'm always starting on the easy ones, right? Why do I start there? Because they're the easy ones. Then now I got to think about this. Okay. Flip that fraction. Shouldn't be difficult, guys. So just flip the fraction. So I'm going to go ahead and plot those. Now I'm going to worry about this stuff, right? But I'm going to look at it in pieces. What's that 4 telling me to do? So Ella, what's that 4 telling us to do? Just in a transformational way, how would you describe what it's doing? Stretch. Stretches happen here. Compressions happen there too. What happened up in the power? There we see with the 1. There we see with that 2 over there. And we want to know that it's a liar too, right? It says +1, so we're going left, right? So shifting it left to right, but we go the opposite way that it says. So what's that saying? Left. Left 4. Okay. So left 4. Okay. So what am I going to do with my points? I'm going to take each one and move them left 4. So, okay. Quite literally, you're just going to grab each of those points. You're going to move them left 4. Okay. This is transformational graphing. This one's a little tricky since it's kind of floating in the middle. But it should be about there. Just make sure it's still above the x-axis when you're done with it. Okay, so we've moved each of those 3 points just left 4. You good there, Jolie? You good there, Jacob? Anybody? And then we look at the -2. So Elijah, what's that -2 doing?
It moves to the right 3. Or 2, sorry.
No, right, not right 2.
Down 2, sorry.
Down 2. Okay. Up in the power is your left and rights. After is your down and ups. Okay. We don't trust H, we trust K. So quite literally, we're going to take all of those points and move them down 2. That one down 2. Oh, no. Down 2. This one again is a little tricky because it's floating in the middle. 1. So here's a 1 space. Here's no space. That should. Go in the order that you see it though, right? The first thing we saw was the left 4, then we saw the down 2. Okay, follow the order of the function. Okay. So there's our 3 points. We can see how they're still making that same curve that they were before, right? The graph's gonna look like that. Then we shifted the graph over here, and now it's gonna look like that. Now we're shifting the graph around here, all right? It's gonna look like that, okay? Right on, Peyton, okay? So something else has changed though, okay? This guy right here, this shifting up and down business, this is gonna have like kind of repercussions. Because that asymptote was supposed to be here on y equals 0, but you notice those points are crossing that line now, right? Well, that's because that line isn't there anymore. That line also got shifted as we moved everything else. So with horizontal lines, we can't move them side to side because they go forever both ways. There's no moving a horizontal line this way. It doesn't do anything. But you can move it up, you can move it down, okay? Up, down, okay? So horizontal lines can be shifted up and down. Remember what it is? It's a y equals line. That y equals can be affected by an up and down. Y is our up and down thing, even though it's a horizontal line. So that horizontal asymptote also got shifted down too. So now it's at y equals -2. And because it's on a different line, it's not on an axis, I do expect you guys to draw that in and label it. So yesterday I told you guys you could just label it because it was on the axis if you didn't feel like drawing it in. Now, because it's not on the axis, I expect you guys to draw it. So remember, it's there for our eyes. And if we don't draw it, then it's not there for our eyes. Okay, exactly what Brooklyn was asking about earlier. The whole point of the asymptote is to help us see things, and if you don't draw it, then you can't see those things. Okay, so if it's shifted, I do expect you to draw and label it. If it's not shifted, you can just label it. Okay, draw and label your asymptote. And then now we use our points and our asymptote to help us draw that curve. So up on the left side, down through those 3 points, flat along that asymptote that we drew on the right side. Okay, just kind of flat along that, parallel to it. Okay. Again, technically it's supposed to get closer and closer and closer, but that's really hard to do. Okay, so just draw it kind of parallel to that line here as it heads off to the right. Should curve up to the left. Domain we can never change. It's always all real numbers. Range, repercussion, okay? That y value has changed, still going up forever, but it's been shifted down too. So now that y value, that lowest y value is now at -2. So that down 2 had 2 after effects besides just changing where the points were. Also changed the asymptote, also changed our range. All right, Jet, good luck. So let's look at something real quick. Okay. Anything you guys want to talk about there on that one? I'm just going to do one more of these with you. I'm actually just going to do this part of it. I want to get rid of this. I think it just makes it too much. Let's change number 5 just to negative e to the x. I'm going to make sure the homework doesn't have anything too wacky on it also before I send you guys off. No, it's good. All right. Okay. So start with that base function. So f of x equals e to the x. Okay, there's our base function. So that's what I'm going to go and get points for real quick. So x, e to the x, -1, 0, 1. Anything to the 0 power is 1. Anything to the 1 power is itself, but what's e equal to? Okay, so in your calculator, you have e 2.7. While I'm here, I'm going to do -1 also. I think it's 0.4, but yeah, so -2.7 and 0.4. Plot those points. Should look something like that. Then I say, hey, what's this doing? What's that reflection doing? Okay, we're reflecting those over the x-axis. What's that look like? I'm 2.7 here, and go 2.7 below. I'm 1 here, I go 1 below. I'm 0.4 here, I go 0.4 below. Or you can just add a negative onto there also. Stretching and the reflecting is really simple mathematically. All I have to do is change those y values accordingly. It's also really easy to do graphically. I just reflected each of those points down. Our asymptote does not change. Okay, it's just that shift up and down that's going to mess with that. Okay, that won't change. But the graph will just curve the other way. Showed you guys that earlier. It'll just curve down to the right. Flat here along that left side. Kind of parallel to the x-axis there. Real quick, domain and range won't change, or domain doesn't change. Range, little tiny change. That reflection has an effect there. Notice how the range flipped around. Okay, goes down forever and maxes out at 0. Okay, so I wanted you guys to see that.